You've made it. The very last video in 12.5. I knew this was going to be long. I didn't quite realize how long it was going to be, but that's okay. We're here. This problem won't take very long. I'll make a quick comment at the end, and then you are done with this section. So you might be asked to sketch the solid when you're given a triple integral that captures the volume. So this gives me the volume of some solid. That's what triple integrals of 1 do. By the way, there's an invisible 1 written there. Make sure you can see that. So let's work through this. So the first equation, since I'm cutting it dy, I know that y is between y equals 0 and then y equals 2 minus 2z. So y equals 0 is easy enough. That's just the xz plane. I should label everything. All right, and so y equals 2 minus 2z. Well, when z is 0, y is 2, so we'll put a dot. And when y is 0, z is just 1. So we'll put a dot here, and we can actually sketch that. And of course, please realize this thing extends along in both directions. And you can envision it like this if you want to. Whoops, I kind of missed, but you get the point. Okay, so this plane is just extending along like that. And it also continues to stretch this way as well, but we'll just draw it like that. Okay, so that's the first integral. We've sketched those bounds. The next one, z, so I've got z equals 0, and then I want to go to z equals 1 minus x. Z equals 0 is just the floor, but then 1 minus x, what is that? Well, let's sketch it in the zx plane. So when x is 0, I'm going to change colors. Let's make this one red too so you can see. All right. So when x is 0, z is 1. So there's overlap. That's cool. And then when z is 0, x is 1. So there's overlap this way. And that's actually it. You just take this thing and you stretch it out in both directions. And you're going to get another plane. And then these planes intersect apparently. Okay, we'll figure that out in just a moment. Finally, by the way, x just goes from 0 to 1. That's what this last integral is telling me, and you can see x goes from 0 to 1. So how on earth are we going to come up with the actual solid here? Well, you're going to have to use your imagination just a little bit and realize that these two planes intersect, and so somehow they're going to intersect something like that, and we want to try to get a little clear on what that looks like. So what we're going to do is we're going to plug one equation into the other. I don't have them both in terms of one variable. I guess I could solve for z in both cases if I wanted to. Yeah, I could solve for z here. I've already got that. Set them equal to each other. Or just plug this one into that one, which is what I'm going to do. So I get y equals 2 minus 2 times 1 minus x. Y equals 2 minus 2. The 2's cancel. Y equals 2x. And so that gives me this line. Y equals 2x is going to be another plane. And it's going to come out and it's going to intersect. And I'm going to get, everything's a little bit off now, unfortunately, with my picture. But let's see if we can make it work. Y equals 2x. So think with me now. When I have this y equals 2 minus 2z, and z is 0, I get y equals 2, so x is 1. So x is 1 is this line. I'm going to hit that. And then on the other side, when I look at the plane z equals 1 minus x, okay, I'm interested in when z is 0, x is 1. Okay, and when x is 1, y is 2. So these things do indeed intersect right like this. And that might have been a little bit hard to follow, the last part. Take a moment though, and make sure that you can at least sketch the picture out here. I'm going to erase some of this stuff. And so now, at this point, the way that I've drawn the red is slightly misleading. The red should go, and it's actually following along here. This is red, okay, and then it keeps going. And we'll just do that. That's going to clean this up quite a bit. And then the blue is also running on this line. It's the intersection line, and it goes that way. So my red graph was a little bit off. The point is, there's the solid. You can see it inside here. And I'll use green. Let's zoom in a little bit, and we can do that and shade this thing. And that's that. Okay, so the drawing is a little bit hard sometimes to make it look good. Might have to erase and adjust like I did. Mine's definitely shifted a little bit, but that's okay. Final comment on this section, just for time's sake, especially with us being distanced now, I'm not going to work through this, but there are similar results for mass and center of mass. So we did some examples with applications of double integrals on how to compute the mass and the center of mass using double integrals. And you can actually do similar things with triple integrals. And so if you're at all curious, I would invite you to read your book. Great job. You made it through section